Hello friends, welcome to the video tutorial on Firebird 5 Robotics Research Platform. This platform is based on Atmega 2560 microcontroller which belongs to AVR architecture based microcontroller family. In this tutorial we will learn how to use interrupt on Firebird 5 robot. So let us look at the agenda for discussion. First we will look at the concept of interrupt and closed loop programming. Then we will learn about interrupt sources and how to use them on microcontroller and Firebird platform. At the same time, we will also learn the registers associated with the interrupts, and finally we write a C program using the concept that we have learned in the tutorial. When we look at the term interrupt, the first thing that comes to our mind is any signal that causes break in continuity of some ongoing process. For example, when we are eating and the phone rings, we stop eating to receive the call. After we are done talking, we resume eating our food. So in this case, the phone call is the source of interrupt. Now let us look at technical view, taking in consideration a microcontroller. In a microcontroller, interrupt signal halts the execution of main program and dedicates processor to another task. During the execution of the main program, if an interrupt occurs, the execution of the main program is stopped and the program counter is loaded with the address of the ISR. The program counter is a register that stores the address of the next instruction to be executed. ISR, or the interrupt service routine, is a small function that needs to be executed when interrupt occurs. After the code in the ISR is executed, the execution of main program resumes from the point where it was stopped. Now let us look at another important concept before we move forward with interrupt, that is closed loop programming. Systems that utilize feedback are called closed loop control system. The diagram displayed depicts a closed loop system. The next question that arises is, why do we need closed loop system? Well, the answer to this is very simple. We need such a system because it enables us to take more accurate decision by taking into consideration the response from the system. There are various examples from daily life which uses feedback. In our house, we are using air conditioner to maintain room temperature. You use remote to vary the temperature of AC. So in this case, AC behaves as a system which is getting feedback from us through remote depending upon our temperature requirement. Thus, we can conclude that feedback is used to make decisions about changes that are to be made to the control signal that drives the system. An open loop control system is one which doesn't have or which doesn't use a feedback system. So there are many sources of interrupts in a microcontroller. In Atmega 2560, there are total 57 different sources of interrupts. These can be broadly classified as timer overflow interrupt, timer compare interrupt, serial interrupt, wire and wireless interrupt, external hardware interrupt. So there are all these sources for interrupt generation. So we are going to use external hardware interrupt. Now moving back to interrupts, let us look at how interrupts are used to calculate the distance moved by the robot. For this, we have a device called as Optical Position Encoder. Optical Position Encoder gives position feedback. The position encoder is divided into two parts. The first part is IR LED and the other is photodiode. They are placed opposite to each other. The disc called as encoder disc cut the path between the LED and the diode to generate an output of high and low pulses. This output from the encoder is connected to the external interrupt of the microcontroller. So left encoder is connected to INT4, that is external interrupt 4 of the microcontroller, and write encoder is connected to INT5, that is external interrupt 5 of the microcontroller. Now let us look at some calculations. The encoder disk has 30 slots, generating 30 pulse per revolution, and the diameter of wheel is 52 mm. From these two values we can calculate the resolution, that is movement in one pulse. So here the resolution is the circumference of wheel divided by the number of pulse, giving an approximate value of 5.44. Thus the pulse count is given by distance covered divided by 5.44. Before working with interrupt, we need to initialize certain register. They are as follows: SREG or AVR status register. It is used to enable disable all interrupts globally using the global interrupt enable bit. Global enable bit is analogous to main switch of our house. Tube light and fan won't even work though their respective switches are on till the main switch is off. So for using an interrupt, you must enable global interrupt and then use any of the interrupt sources. So we are going to enable the interrupts globally because we are going to use the interrupt. So that's why we have put the value of global interrupt enable bit as 1. Rest other bits are kept as 0 because we are not going to use them at this programming exercise. So the value of SREG is 0x80. Next is EIMSK or external interrupt mask register. This register is used to enable or disable the interrupts individually. So this is similar to switch off your home appliances. You need to switch on the switch only for the appliance you wish to use. Here we require INT4 and INT5, as these two external interrupt sources are used for the two motors. Hence they are set as 1. If you are using any other source, you have to give a value of 1 to that particular register also. So there are 8 sources of external interrupt, and hence 8 bit are used according to the corresponding interrupt source you are using. So in this case, value of EIMSK will be 0x30, as we have enabled only interrupt 4 and 5 while rest are disabled. Interrupt is generated when microcontroller receives the signal from the source. As a user, we can select how to use that source to trigger interrupt. We can trigger interrupt when signal goes from high to low or from low to high. So EICSR or external interrupt control register are used for this purpose. So this register has two parts. EICRA is associated with external interrupt 0 to 3. Each interrupt has 2 bits which we can use to set the way we want external signal to be used for generating the interrupt. So consider ISC31. In this case, 3 is the number of the interrupt source which we are using. If we are using external interrupt 3, we have to use ISC3, and it has 2 bits associated with it, ISC31 and ISC30. Similarly ISC21, ISC20 and etc. So we will explain significance of bit in coming slides. As we are not using external source 0 to 3, the value of this register is set to EICRA is equals to 0x00. EICRB is associated with external interrupt 4 to 7. We are using external interrupt 4 and 5. So set value of ISC51 as high and ISC50 as low. Similarly for ISC41, value should be high, and for ISC40, value should be low. I will explain in next slide why I have put this value as 1 and 0. So the value for EICRB will be 0x0A. Let us see the significance of 2 bits we used in EICR register. So if we put both bit as 0, interrupt is triggered at low level of signal. Similarly, we can generate interrupts at rising or falling edge of the signal. So in our case we will be using falling edge. So that's the reason why we have set resistor bit as shown in the previous slide. That is ISC 51 was 1 and ISC 50 was 0. And similarly for the ISC 4 register. Now whenever an interrupt is generated, a set of program is executed which we as a user want our system to do. This program is written inside ISR or the interrupt service routine. So the format of ISR for external interrupt is as follows. To create an ISR, we write an ISR function. Here we write ISR in brackets int and the interrupt number underscore VECT and then bracket close. So within ISR we write the program we wish to get executed when interrupt occurs. Now let us look at the syntax for the writing C program. First we need to initialize port to which encoders are connected. To initialize the left encoder we use function left underscore encoder underscore pin underscore config. So this left encoder is connected to pin 4 of port E. So we have defined that pin as input by writing that particular pin as 0, and in port E register we have given a value of 0x10, so to enable the pull-up register for port E pin number 4. Similarly, to initialize the right encoder we use the function right underscore encoder underscore pin underscore config. So the right encoder is connected at port E pin number 5. So this pin is defined as input pin and the pull-up register is activated for that pin. The register that we have discussed tell the microcontroller how it has to function when interrupt occurs. Thus we have to use them in the initialization of interrupts. The left encoder interrupt initialization is done using left position encoder interrupt init function. So the value of EICRB and EIMSK register is same as we have discussed in the slides, and similarly we have initialized the right encoder interrupt by putting the value in EICRB register and EIMSK register. The CLI and SEI are the functions for clearing the global interrupt and setting the global interrupt. So whenever we are initializing any interrupt, we should first globally disable all the interrupts, then initialize the interrupts, and then should set the global interrupt. Now let us look at the demonstration. We will start with writing the C program for using interrupt on Firebird 5 platform in Atmel Studio 6. You can open Atmel Studio by clicking on the icon. Follow the steps for creating new project as demonstrated in documentation of Atmel Studio 6. For now I have written a program and have opened it in the Atmel Studio 6 IDE. Here is the complete program. As in all the programs, we have the first line as has defined FCPU 14745600. This sets the clock frequency in Hz on which the robot is operating. It depends on the crystal frequency attached on the robot. So in case of Firebird 5 robot, the crystal frequency is 14745600 Hz. Then we have the standard header files like avr.io.h, avr.interrupt.h, util/delay.h. Then we have defined some variables which we are going to use in our program. Next we have defined motion pin config. This function is same as the one which we have used in earlier in motion control. So we have defined our DDRA on which the motor pins are connected as my output device, and DDRL on which the enable pins are connected as output pins. Then we have defined left encoder pin config. So we have defined port E pin number 4 as our input port. Then we have our write encoder pin config, which defines port E pin number 5 as my input pin for write encoder. Then in next function we have made a universal function as port init, and inside that we have called all the port configuration files. Next functions, it is the same as the one which we have discussed in the slide. It is the left position encoder interrupt initialization. So we have initialized the registers and have given it the values as we have discussed in the lectures. So you can use the same function. Then for write encoder also we have defined a similar function. Then we have here defined the interrupt service routine ISR int 5 underscore vect, and inside that I have used shaft count write plus plus. So in this program we are going to demonstrate that the robot will move forward by 10 centimeter. So for that we need to count the pulses. So we are going, whenever there is an interrupt, in that interrupt we are incrementing the count of this variable shaft count write. Similarly we have ISR int 4 underscore vec, which is the ISR for left position encoder, and inside that I have incremented the variable shaft count left. Then I have motion set, which you all must be aware of as you have done the motion control tutorial. Then we have defined a forward function and stop function. Then we have a function called as linear underscore distance underscore mm. So let me go to the main program first, then I will come back to this part. In the main program I have called the function init devices. So in init devices I have, this is the standard functions which we are using always. So we have cleared the global interrupt. Then we have called the function port underscore init, which has the function for all the pin configurations which we have made, which is here. Okay, so it has motion pin config, left motor pin config, and right encoder pin config. Then we have the initialization for left encoder and right encoder, and then we have set the global interrupt. Then we have called a function forward underscore mm underscore in bracket 100. So let us see what is forward underscore mm function. So this is the forward underscore mm function in which we have written forward and call another function linear distance mm. I need to pass a parameter in this function which is equals to the distance which we want to move in mm. Okay, so if you want to move 10 centimeter you have to give 100 mm. For 20 centimeter accordingly you have to give 200 mm. So in linear underscore distance underscore mm we have used the variable required shaft count. This required shaft count is equals to the distance in mm divided by 5.338 or 5.44. So this means that suppose if we want to move 10 centimeters, so for moving 10 centimeter we need to count the number of pulses. So that pulse is stored in this required shaft count. Then we have a while one loop here, and inside while one I have compared the shaft count with the required shaft count. Okay, so here I have just, this is just a typecast which is done here. Okay, so you must be aware of as you are knowing C programming. So I have just compared it with the shaft count right. So whenever a interrupt is occurring, so my ISR will be called. So because my right motor encoder is connected at 5th external vector, so inside that whenever there is an interrupt this shaft count will increase. So if there is the first pulse, so this count will increase to 1. For second pulse it will increase to 2. So now in this way whenever there is an interrupt this count will go on increasing, and when this pulse will become equals to this value, that is required shaft count, it will come out of the loop and it will stop. So in this way the robot will move forward till this shaft count right is less than required shaft count, and once that count becomes greater the robot will stop. So this is a very simple and basic program which we have written. So now let me build the file. So I have successfully built it with 0 errors. So now let us open the AVR bootloader software. Now here select the COM port number, in my case it's COM5, set the baud rate as 115200, select your controller which in our case is Atmega2560, then browse for the hex file. So I have written the program and saved it on desktop with the name of interrupt. Okay, and inside interrupt debug folder and the hex file. Now switch the robot in bootloader mode by pressing and releasing the reset switch with boot switch pressed, and then release the boot switch. Then click on the program button and wait for program to load. Once the code is successfully loaded, switch on and off the robot. So here you can clearly see that the robot has moved forward by 10 centimeter and has stopped. So here we have successfully understood the concept of interrupt and how to use interrupt on Firebird platform. We successfully wrote the program for moving the robot in forward direction by 10 centimeter. You can experiment with code and try to make robot rotate by certain desired degrees. With this we have come to end of this tutorial. Thank you for listening. For any queries or doubt you can visit qa.e-yantra.org. This is Saurav Sandalia signing off.